Our journey about constraints begins in northern India, during the Gupta era, around the 6th century, long before computers, long before artificial intelligence. A game appeared that transformed conflict into thought. It was called Chaturanga, a battlefield reduced to a board, an army reduced to pieces, war reduced to movement. The name referred to the 4 divisions of an army: infantry, cavalry, elephants, and chariots. But the genius of the game was not war. It was an abstraction. A living conflict became a symbolic system. A chaotic battlefield became a structured space. And inside that space, every move mattered. From India, the game traveled, through Persia, into Europe. Its name changed. Its pieces changed. Its rules evolved, but its central idea survived. A bounded board, a shared state, and a future shaped by every move. Over centuries, chess became more than a game. It became one of humanity's most recognizable images of thinking. A place where intention becomes visible, where memory becomes position, where strategy becomes movement, not through speech, but through states. In 1950, mathematician Claude Shannon attempted to measure the true scale of chess. From a single position, a player may face roughly 30 to 40 legal moves. Even the number of legal board states already reaches beyond direct human comprehension. But when these positions recursively branch across entire games, the number expands dramatically. Shannon estimated roughly 10 to the power of 120 possible chess games, a 1 followed by 120 zeros, a number vastly larger than the estimated quantity of atoms in the observable universe. No human explores this space exhaustively. The space is too large, and yet every chess player must navigate it. But not every chess player traverses the space the same way. For a beginner, chess is not yet a language of patterns. Every position must be explored consciously. Every threat must be held in working memory. Every possibility must be evaluated manually. In the paper, What Makes You Quit at Chess?, Harry Heron and collaborators analyzed approximately 1 million online chess games and found that resignation and abandonment behavior are associated with player rating differences. In practice, games between players with a larger rating gaps appear more likely to end prematurely than games between players of similar strength. But what does a rating difference actually represent? When a grandmaster looks at a chessboard, they do not actually see 32 separate pieces. As William Chase and Herbert Simon demonstrated in their 1973 study Perception in Chess, experts reorganize the board into higher-order symbolic units called chunks, allowing complex positions to be processed as meaningful structures, rather than disconnected elements. A novice player cannot compress the position efficiently, so they compensate by performing a far more exhaustive search through the space, manually checking threats and continuations that stronger players recognize almost immediately. In Cognitive Load During Problem Solving, John Sweller argued that complex problem solving can overwhelm working memory when too many interacting elements must be processed simultaneously. This compensatory search dramatically increases cognitive load. More possibilities must be maintained. More uncertainty must be stabilized. More corrections must be recomputed after each mistake. As fatigue accumulates, move quality deteriorates, and resignation becomes increasingly likely. Ultimately, an expert sees compressed patterns, threats, and strategic relationships. The board is the same. The rules are the same. But the grandmaster has not escaped complexity. They have learned to compress it. But everything changed on May 11th, 1997, when world chess champion Garry Kasparov lost a decisive 6-game match to IBM's Deep Blue. For decades, the grandmaster had represented the highest known form of human symbolic compression, the ability to reduce overwhelming complexity into navigable strategic structures through intuition, abstraction, and pattern recognition. But Deep Blue operated through a fundamentally different navigational system. It could traverse and evaluate the symbolic space at a scale no human player could sustainably maintain. The asymmetry that once separated the novice from the grandmaster had emerged again at another scale. The human master now occupied the same position the novice once held, forced to compensate against a system capable of navigating the symbolic space more efficiently than biological cognition could sustain. More possibilities had to be maintained, more uncertainty had to be stabilized, more continuations had to be evaluated under mounting time pressure. While human grandmasters managed a few scattered victories against software in the years that followed, the window effectively closed in November 2005. For more than 2 decades since, no human has consistently defeated top chess engines under standard tournament conditions. And eventually, even human versus machine competition ceased to define the frontier of chess itself. Today, the leading edge of the game exists primarily between machines. Systems competing against other systems at scales of evaluation, traversal, and compression no human player can realistically maintain. The board remains the same, the rules remain the same, but the dominant navigators of the symbolic space are no longer human, which invites a deeper question. What happens when cognitive load accumulates faster than the brain can stabilize uncertainty?